Hey! Hey! I'm Mr. O, here with another moment at the Children's Museum of Houston. We've talked about pennies before, namely, they're not all that they appear to be. While they may look like they're mostly made of copper, that's not entirely true. Pennies made before 1982, like this one, are pure copper. However, by 1982, the cost to mint a penny out of pure copper costs more than the value of the penny itself. So, pennies made after 1982, like this one, are actually made of mostly zinc with a very thin coating of copper on the outside to disguise it to look like a pure copper penny. Think of it like this cookie. While on the outside there's chocolate, on the inside is cookie and peanut butter. In fact, if you cut a post-1982 penny in half, you can quite clearly see just how thin the plating of copper is. Putting copper onto the outside of a penny is not nearly as simple as, say, pouring melted chocolate onto a cookie. See, the problem is, zinc has a lower melting point than copper. So if you pour molten copper onto zinc, the zinc will melt, leaving you with just a blob instead of a penny. Instead, the US government uses electroplating, a process where they put a thin layer of metal on top of another metal using electricity. But to really understand this process, we're going to need to explore salts. When chemists talk about salts, they don't usually mean table salt. Rather, they mean metallic salts, of which table salt is one kind. Metallic salts are a type of substance made of a metal chemically bonded with one or more nonmetals. See this line on the periodic table of the elements? Elements on this side of the line are metals, and elements on this side of the line are nonmetals. When metals chemically bond with nonmetals, they form entirely new substances, metallic salts. So by selecting the right metallic salt, you can plate the metal from the salt onto another metal. But more than that, an essential piece to electroplating is how the metallic salts are bonded. When a metal and a nonmetal bond together to form a new substance, they form a very special bond called an ionic bond. To keep it simple, in ionic bonds, the molecules, the tiny particles that make up each substance, get charges. The metals become positively charged, and the nonmetals are negatively charged. The opposite charges are attracted to each other, sort of like the north and south poles of a magnet, holding the molecules together to form the metallic salt. When you get enough of these particles sticking to each other, you get a solid form of a metallic salt, often in crystal form. But because of the structure of the positive and negative particles, something special happens when you put them in water. Pretend this is pure water. Pure water is nothing but water molecules, so electricity has a pretty hard time flowing through it. Electricity needs a medium to flow through it with charged particles. That's where metallic salts come in. Not only do they contain the metal that you're going to plate onto something, but because they are ionically bonded, they typically dissolve in water. Water molecules are able to spread out the positively and negatively charged particles. Now that these particles are so spread out, electricity can flow through the solution and electroplating becomes possible. Generally, electroplating is used to combine the strengths of two metals. For example, taking zinc, a non-corrosive metal, and a strong metal, like steel, and coating the zinc over the steel to make the steel non-corrosive. Or take, for example, plating gold on top of a less expensive metal to make jewelry that appears more expensive than it really is. You know, we should do the opposite of the US Mint. Instead of plating copper onto a zinc coin, we should plate zinc onto a copper coin. Let's get electroplating! Science is fun, but it can also be dangerous, so always have a responsible adult helping you. For electroplating, you'll need a 9-volt battery, a 9-volt battery clip, 2 alligator clips, 2 clothespins, vinegar, Epsom salts, which you can get at your grocery store or pharmacy, sugar, and a cup. You'll also need to get strips of zinc metal, which you can usually order online from science teaching suppliers. Oh, and make sure to get a nice shiny penny to plate. Dull pennies will work, but they don't look as nice. First, put the zinc into 1 cup of white vinegar. Now, just let that sit for at least 2 hours. After a few hours, remove the zinc and add 4 teaspoons of Epsom salts. Then add about 2.5 tablespoons of sugar to the vinegar and stir it all up. Put the 9-volt battery clip onto the 9-volt battery. Know that the red wire is the positive end and the black wire is the negative end. Use an alligator clip to connect the zinc to the positive terminal of the battery, that's the red wire, and use a clothespin to clip it in place. Then use an alligator clip to connect the penny to the negative end of the battery, that's the black wire, and use a clothespin to clip that in place. Make sure that the penny and the zinc strip do not touch. You should almost immediately see bubbles forming on the outside of the penny. That means that the electroplating is working. And now we wait. All right, how about I tell you what's going on while we wait? First, let's go back to step 1. Vinegar is a type of acid. By putting in the zinc metal, it reacts to the acid, forming positively charged particles of zinc. So, because Epsom salt, or in chemical terms magnesium sulfate, is a metallic salt, electricity is able to flow through the solution. The penny is connected to the negative terminal, so it has a negative charge. Now, remember that zinc metal in the solution has a positive charge. Because opposites attract, the zinc in the solution is attracted to and plates the outside of the penny. But since zinc is leaving the solution, the zinc from the strip is going into the solution to replace it. As for the sugar, it prevents the Epsom salts from growing large crystals, creating a brighter, harder plating. After about 10 to 15 minutes, remove the penny, rinse it off, and then carefully dry it, and you'll see a nice layer of zinc over the surface. The longer you let it go, the thicker the coating. Now, this is just a demonstration of electroplating. It's not like it's industrial style electroplating, so the zinc will eventually wear off. But in the meantime, have fun making your pennies glitter, even if they aren't made of gold. This has been another Oh Wow moment from the Children's Museum of Houston. We hope your mind can come out to play.